Hi everyone, welcome to the channel. In this video I am going to cover everything about pointers. I have listed down all the topics here in such a way that you will be able to relate all the concepts to each other. So either you are preparing for any interviews or for your exams, then this video is going to help you a lot. So please stay throughout the video to understand all the concept in very easy to understand manner. Without any further delay, let's start our discussion with the definition of this pointer. This pointer is similar to any other normal variables. This normal variable is stored somewhere in the memory. Let's say it is on 1000 memory location, and if I define it here with value 5, then this memory location will contain value 5. So similar to this normal variable, our pointers also stored somewhere in the memory location, let's say 2000, but this is a special type of variable which stores the address of another variable. Here I have assigned address of this variable var to this pointer. So now our pointer ptr, which is stored at memory location 2000, will contain the address of this variable var, which is 1000. So now this will contain or store 1000 here. So here we can say that our pointer ptr is pointing or referring to this variable var, which is known as referencing. And with the help of this pointer, you can access or change the value of this variable. And how can you do that? You can do that with the help of asterisk key operator or star symbol. If I write here star ptr equals to 10, then this value will be changed from 5 to 10. This is known as dereferencing. The next question you can have, why do we need this pointer? There are many use cases of this pointer that we apply in our day-to-day programming. The first use case you can think of, if you have any array of, let's say, n elements, and you want to iterate over it either in forward or backward direction. So for that, what you can do, you can store the address of any particular element. Let's say I am storing the address of some x element. This could be either 0th element or 5th element or nth element. And from there, you can either traverse in forward direction using ptr++. The size of this integer is 4 bytes. So when you do ptr++, then the address of this pointer, let's say this is stored at memory location 100, then this will be stored at memory location 104. Its next element will be stored at memory location 108. So after doing this plus operation, incremental operation, this pointer ptr will point to the next element in the array. Suppose this was pointing to 100. So after this operation, it will point 104th memory location. And in the same way, you can traverse in backward direction as well. And how can you do that? With the help of decremental operation, minus operation. Let's say it was pointing to 104th memory location. So after this operation, it will point to 100th memory location minus 4th memory location. Another use case you can think of, let's say you want to create memory at runtime, and how you do that? With the help of malloc or calloc, right? So suppose with the help of malloc, you have allocated 4 bytes of memory, then this will return you some address, right? This will return you address which you need to store in some pointer, and our pointer stores address, correct? So you need to store this one into some pointer. At runtime, you cannot create static arrays, right? To deal with runtime memory allocation or dynamic memory allocation, you need these pointers. Third use case you can think of, linked list. This is widely used in our programming. In linked list, we used to have several nodes, and each node contains 2 fields. One is data field and another is the pointer field. This data field contains some kind of data, and its second part which contains the address of next node. Similarly, this node's n2 second part will be containing address of n3, and lastly it will contain null. So here also you need some kind of pointer, correct, to store the address of next node. There are many other use cases like we also use for call by reference. In call by reference, what we do, instead of passing values, what we do here, we pass the address here, means we pass the reference of variables here. Here the difference between call by value and call by reference is, for call by value, we directly call with the value from the main, right? And for call by reference, we pass the address of these variables from main. And what happens here when we pass by address, then address of this x, let's say x is stored at memory location 100 and y is stored at memory location 104, then this memory 100 will be copied to pointer A. So now our pointer A will refer to memory location 100 and pointer B will refer to memory location 104. So whatever change we are doing here, that will be directly reflected here. Suppose earlier we had 1 and 2 here, and we execute or call our swap function here with call by reference by passing address. These two values will be interchanged after executing these 3 lines. So for these purposes, we use pointers. I have taken many references here. I could have missed something. If you know something else, please write into the comment box so that other people can see it and get the understanding from there. Let's move further with another question. What is the size of these pointers? Pointers we can take of any data type. Either it could be with integer data type, or it could be with character data type, or with float data type, and these pointers are stored somewhere in the memory location, right? So these all will be stored somewhere in the memory. Let's say this is stored at memory location 1000, this is 2000, this is at 3000 memory location. So how much size will be allocated on these memory locations for these pointers? To store these pointers, how much memory we need? In one way you can think of this integer is having 4 bytes, so our pointer need to store 4 bytes here to store the address of any variable, and for character we need 1 byte of memory location to store. You can think of like that, but this is not true, because here we need to store address here, right? What we need to store? Address of integer variable here. Here we need to store address of character variable. Here we need to store address of float variable. So every time we need to store addresses here. So it doesn't depend on these data types. It totally depends on what size of your processor, or in another word you can say this depends on CPU architecture. If your CPU is of 8-bit, let's say, then we need to store just 1 byte of address into this memory location. And if your CPU is of 16-bit, we need to store 2 bytes on this memory for the pointer. We are storing address of the variables, right? So to store the address for 16-bit, we need 2 bytes here. Similarly, for 32-bit, we need 4 bytes, and for 64-bit, we need 8 bytes to store on this memory location. Next, understand what happens when we try to access any uninitialized pointer. Suppose you have declared a pointer, but this is not initialized, and you try to access this memory location or try to update the value at that memory location, let's say with 4. So first thing you need to understand, what is the memory location pointed by this pointer? This pointer PTR, let's say it is stored at memory location 1000, and what it is used for? It is used to store the address of another variable. Then what address it has currently? We have not assigned anything. It is uninitialized till here. So this pointer will contain any random memory location, correct? This could be anything. You are not having any idea about this random memory location, and you are trying to update the value over this random memory location. And suppose this memory is there for some critical sections where, let's say, your OS is stored, and you try to update that memory location, then it will not only crash your program, it can crash your OS as well. Because of this jungly type behavior, these uninitialized pointers are known as wild pointers. And what should we do for this? To avoid these wild pointers, either we can initialize this pointer with null or with the address of another variable. So when you do this, in case of when you assign with some address of with this variable and you try to access or update the value at this memory location pointed by this pointer, then this will work well. There is no problem. And when you assign with value null and you try to access here, and since this pointer is pointing to null means pointing to nothing, null means 0, so it is pointing to 0 memory location. So you will get at least error and you can correct your code. At least you are not crashing the system. And when you assign null to this pointer, then this pointer is known as null pointer, which is pointing to nothing, which is preventing us from any disaster scenario like OS crash or system crash or program crash. The next question we can have, suppose we have taken integer pointer here and I have two variables, one with integer data type and another we have of character data type. So till now I had used ptr equals to address of integer data type. I had never used character data type. If I write here ptr equals to address of character data type, this is a character variable, right? So this is possible. Now the question is whether this is allowed or not. Let's understand this with positive scenario first. So in positive scenario, what we do, we store the address of integer variable, and this integer variable will be having size of 4 bytes. And since this pointer is pointing to our integer variable, so whenever we do dereferencing with the help of this pointer ptr, let's say I'm writing here 0 cross 100, and since the data type of this pointer is integer, so it will try to update how many bytes on the memory. It will update 4 bytes on the memory, correct? But in this scenario, let's see, this character variable is having size of just 1 byte and our pointer ptr, which is size of 4 bytes because it is of integer data type. So when we do dereferencing, still this will try to update 4 bytes on the memory location. But what is the size of this character? Just 1 byte. So we'll be having conflict here. Our pointer will try to update 4 bytes here, but the actual allocation for this variable is just 1 byte. So we should always take or store the address of same data type into these variables. If we have integer pointer, then we should store only integer variable address here. To store the character variable address, we can take character pointer, and here we can store address of C data, which is type of character. Let's move one more step deeper. Here I have taken character variable, which I have assigned with value 0. So how many bytes will be consumed by this variable? This is having type of integer, so it will contain 4 bytes on this memory, and we have initialized with value 0, so it will contain 0. Its address is, let's say, 100, 101, 102 and 103. In normal scenario, when we take integer pointer and assign the address of this variable to it and try to update the value with the help of star ptr, so now its 0th location will be updated from 0 to 4 and others will be same. But when we do typecasting, let's say I am typecasting this pointer, and then I am doing dereferencing, then how many bytes will be changed by this? And because after this typecasting we have taken character pointer, so this dereferencing will update only the 0th byte here. And let's say with this typecasting I want to update the value of this second position. And how can we do that? Currently this pointer ptr of character type is pointing to memory location 100. So to point this memory, we need to increase this character pointer. I am considering typecasting as well. So if I increase this by 2, right? 2, and then if I do dereferencing here and try to update the value, then this second index will be changed from 0 to 2. So similarly you can change for this also, this also. A single byte you can access from these 4 bytes. Similarly, if you want to change 2 bytes on the memory, then in which data type you should change? Here for 1 byte you change to character, and for 2 bytes you need to change it into unsigned short pointer. So when you are typecasting to this, it will access 2 bytes on the memory. So with the help of this kind of typecasting, you can play with these memories. One thing we understood from the last part is we can assign the address of this variable, which is having type of integer, to this integer pointer, but we cannot assign the address of this character to this pointer because this is having different data type. So to solve this problem, you can take void pointer, which doesn't have any data type associated with it, and you are allowed to store any kind of variable address, either it is integer or character or float or anything. So in these void pointers, you can store the address of any variable. It could be user defined data type as well, like a structure or union. These addresses also you can store in this void pointer. Only the problem is, since this void pointer is not having any data type, so while dereferencing for these void pointers, compiler is not knowing how many bytes it has to update on the memory for this dereferencing. Let's say if I'm writing here star ptr equals to 4, so our compiler doesn't aware anything about how many bytes it has to update on the memory, either 1 byte or 2 byte or 4 bytes or 8 bytes. It is not aware. So to solve this problem, you need to typecast this first before accessing it. You need to assign or tell the compiler in what data type you want to access it. If you are assigning or typecasting to integer, then it will update 4 bytes on the memory. And if you are typecasting to, let's say, short pointer, then this will update only 2 bytes on the memory. And if you are, let's say, typecasting to character pointer, then this will update only 1 byte on memory. And these void pointers are widely used in dynamic memory allocation. So in dynamic memory allocation, we use malloc or calloc, and both returns void pointers. So to use these pointers, we need to typecast it. Let's see for malloc first. Let's say you have created memory of 4 bytes using malloc, and since it will return void pointers, so you need to typecast it. Let's say I'm typecasting to character pointer and assigning this address into the pointer ptr, which is again type of character. Similarly, if you need to store this one into the integer pointer, then you need to typecast it into integer pointer here before assigning to pointer ptr. Next, let's understand for calloc. Calloc stands for contiguous memory allocation. It takes 2 arguments. Its first argument requires number of blocks and its second argument requires number of bytes for each block. Let's say you want to create memory for 3 integers. So you have 3 blocks here, and since you want to create memory for 3 integers and integer size is 4 bytes, so your each memory, or you can say your each block, requires 4 bytes. So this is 4 and this is 3. So first argument I am giving 3 number of blocks, and second argument I am giving number of bytes for each block, that is 4. You can write here like size of integer, so it will directly give 4, and this will also return void pointer. So you need to typecast it. Suppose I need to store it into integer pointer. So for that, what I need to do? I need to typecast it into integer pointer. Similarly for character, you can typecast it into character pointer, and so on. And sometimes in interviews, you might ask to explain the difference between malloc and calloc. These two are used for dynamic memory allocation at runtime, that is for sure, and both allocates contiguous memories. Here the term contiguous, this means, here my drawing is bad, please adjust with that. Suppose this is your memory and you are allocating memory with the help of malloc or calloc, so both will allocate contiguous memories. That means, let's suppose it is allocating from here, so contiguously it will allocate memories from here. It will not miss anything. It's not like it misses here, this will not miss. Everything will be allocated. It cannot be like 2 bytes it allocated here, then 2 bytes it allocated here, 2 bytes it allocated here. It's not like that. Contiguous means continuously it is allocating memory, so that whenever you are dealing with these pointers and you do plus plus operation, you can traverse through the entire allocated memory without the failure. So this is the similarity, but this was the important concept, that's why I explained here. And malloc takes just one argument, right? Number of bytes. How many bytes of memory you want to allocate? So it takes just one argument, correct? But your calloc accepts 2 arguments. One is number of blocks, how many blocks you want to create memory for, and what is the size of each block. I'm just writing size of block. So it takes 2 arguments here to allocate memory. And one major difference is here, whenever you are allocating memory with the help of malloc, so let's say you are creating 4 bytes of memory here, okay? So these 4 bytes will not be initialized. This will be uninitialized state. So it will contain some random value here. But in case of calloc, it doesn't only allocate memory, it also initialize these memory locations with value 0. So this is the major difference here. And there is a serious problem that a programmer does when they are dealing with these dynamically allocated memories, that is memory leak. Whenever you create memory dynamically with the help of malloc or calloc, then these dynamically allocated memories are allocated from your heap area, and these are limited area taken from your RAM. So whenever you are allocating these memory dynamically, and whenever you are done with these, you don't need it anymore, then you should delete these memories or free up these memories so that those memory spaces can be utilized for some other purpose. So when programmer forget to delete these memories, for example, this allocation you might have done in some function, let's say, and you have not returned anything from here, and when you execute this function from your main, so after executing this line in the main, you don't need these pointers. The scope of these pointers means these local variables are over, because the scope of these local local variables are limited to this function itself. You can't use outside of this function. So you can't use in the main. So whatever memory you has allocated before here, so this will be still allocated, but you are not going to use this memory. So what you are doing here, you are leaving with some leakage in the memory, right? So that is the problem of memory leak. So to overcome from this memory leak, you should always delete these memories or free up these memories using free function. So when you write here before return statement, before this return statement, if you just place this free function here, it will delete your dynamically allocated memories, and this will increase your system performance, right? Let's understand another concept called dangling pointer. From the name itself, you can relate these pointers are hanging freely. So whatever memory location it is referring, these are either deallocated or these are gone out of scope. Let's understand both with examples. Let's suppose you have created 4 bytes of memory dynamically using malloc, and you have assigned to this pointer ptr, and after some time you have freed up this memory using free function, and after freeing, somehow you try to access this memory using star ptr. You are doing dereferencing here. So this statement will try to access this memory, whatever 4 bytes of memory you had allocated with the help of this pointer. This will try to update value onto this, but these are deleted at this line, right? You have only address stored in this pointer, but these are deleted, or you can say deallocated. So this is going to give you error. Or if you try to read this memory, suppose you want to print the value of this pointer, then this will give you some garbage value, any random value it can give. So how can you avoid this scenario? So whenever you are freeing up or deallocating this memory, so after deallocation you should always assign this pointer ptr here. After freeing up, you should assign this pointer with null, so that whenever you are going to use further or trying to access event, instead of giving garbage value, it will give you error, and you can always go back and correct your program code. Another example here, suppose you are taking any local variable inside this function and you are returning the address of this temporary variable. So from main, whenever you are calling this function get address, it will give you address of this temporary variable, and it will be stored into this pointer. And since the scope of this local variable is valid inside this function itself, and whenever it is exiting from here with return statement, these memories will go out of scope. So even though you are returning address from here, this memory itself is not valid. So even though you print here or try to access it using star ptr, you are going to again receive some garbage value. So how can you avoid in this scenario? So there is a way. It's very simple. You take this local variable as a static. So whenever you are taking this local variable as a static, then this variable temp will exist throughout your program execution, not only inside this function. You have increased the scope of this variable temp, and it will exist throughout your program execution. So you'll be getting correct value after this static use. Next, let's write a program to calculate the size of a variable without using size of operator. This is provided by our library, right? So without using it, how can we calculate the size of any variable? This is a very simple question. Let's suppose you want to calculate the size of this integer variable var, and we know that size of this integer variable is 4 bytes, right? Suppose it is stored from 100 to memory location 103, and when you are referring this with pointer ptr, then this pointer will store the address 100, and if you do ptr plus plus incremental operation, then this will point after this line your ptr, this will point memory location 104, correct? So simply if we subtract ptr here, ptr plus 1 minus ptr means 104 minus 100 operation we do, so I'll get the size, right? So what I'm doing, I'll typecast this ptr plus 1 minus ptr. This typecasting is required to get the size, otherwise you will get the value 1. If you simply do ptr plus 1 minus ptr, so it will perform simple arithmetic and it will give you the value 1. But when you do typecasting here, ptr plus 1, it is referring to 104 and you have typecasted it, so it will give 104 and this will give 100 and you will get the actual size. This question is mostly asked in interviews. Next, understand the difference between pointer to constant and constant pointer. These two are totally different concepts. When you say pointer to constant, it means our pointer ptr is pointing or referring to a constant variable. This variable is constant, its value, let's say it was 1, and our pointer is storing the address 1000. So here our variable is constant. You cannot change this value 1 from here. If you write ptr star ptr equals to 5, then this will give you an error. You cannot perform this operation, but you can change this pointer from variable var to another variable. Let's say you have another variable var2, let's say. So here you are allowed to write ptr equals to ampersand var2. You can change this pointer from var to another variable address. That is possible, but you cannot change the value at this memory location. And next one is constant pointer. Here our pointer is itself constant. Here you are allowed to change the value of this variable. You can change from 1 to another value, let's say 5. This is okay, but you cannot change the pointer address here. If you write this, this is going to give you error. Here this one you can write in ulta way also, const int, both are same. The placement of this star symbol is only important here. If it is after constant, then it is pointer to constant, and if it is before const, then our pointer is itself constant. Next, understand what is double pointer or pointer to another pointer. Suppose you have integer variable var which is storing value 1 and its address is 1000, and you are storing this address 1000 into a pointer, let's say ptr, then our normal pointer is pointing to the address of this variable. And if you take another pointer, let's say dptr, which is storing the address of this pointer, which is 2000, then this is your double pointer, which is pointing to another pointer. This cannot point to this variable address directly. And how you declare double pointer? We can declare it with double star symbol. This is mostly used in two-dimensional array. Let's understand this with an example. Let's suppose you have array of a string which has 3 elements: India, Pakistan and China, and we want to take, this will be character because we are storing strings here that we can store in character pointer, right? Here I am taking double pointer ptr where I'll store the address of 0th string. So now our double pointer, this ptr, is pointing to this first element, and if you print here this string value, you will get a string India here. And if I increment this pointer by 1, so now this is pointing to the next element, Pakistan. So same print if you do here, it will give you a string Pakistan, and if you further increase this pointer and print the value of this string, it will give you China. That's how we use this double pointer to deal with two-dimensional array. Next, understand about array of pointers. Let's suppose you have taken array of 3 elements, then you have written a star ptr of 3. So when you execute this line, your compiler will understand this is an array of 3 elements because precedence of this braces is higher than this star symbol. So your compiler will execute this first, and it will come to know this is array of 3 elements. And what are these 3 elements? These 3 elements are nothing but 3 pointers. This is also pointer, this is also pointer, and this is also pointer. How it will come to know? When it sees a star symbol here. So now you can assign its 0th element with address of a of 0. You can assign next element of this array, this one, with address of 1, and similarly for second element. So this is your array of pointers. Next, let's see about pointer to an array. Here we have single pointer which is pointing to an array. Suppose you have taken array of 3 elements, 1, 2, 3, and then you are taking a pointer ptr. Now this is a pointer because I have used braces here, which will be executed by compiler first, and it will come to know this is a pointer. And then I'll write 3 here, which says this pointer is pointing to array of 3 elements, right? This 3 element could be anything, that depends on what we are assigning to it. And if I assign array A here, so now our pointer ptr, this one, is pointing to this array. And suppose you had taken two-dimensional array, I'm just extending it, I'm taking another array of 3 elements here, and if I increase ptr by 1, so earlier this pointer was pointing to first element, so after doing this operation, plus operation, this pointer ptr will point to another array, the next array. So if you print here for star ptr, it will print 4, 5, 6 here. And how can you print these values? Yeah, it is simple. Here this pointer was pointing to the first element. So if I write ptr and use a star operator, it will give me 1. To get the next index, what I have to do? I need to simply increment this by 1, and it will give me second index value. It will give me 2. Similarly, for this you can use +3. And when you do ptr++, then it will point the next array, and here also simply when you do star ptr it will give you 4, and when you do +1 it will give you 5, and if you do +2 it will give 6. The next question, can we perform arithmetic operation on these pointers or not? The answer will be yes. Till now I have used many times. You could have seen I was using ptr++ or ptr-. So this is incremental operation and this is decremental operation, right? So these two arithmetic operation we perform very often. We also perform addition operation. We increase the pointer and assign it back to this, which increments the pointer by 2 elements. Let's suppose this was pointing to some integer variable which was having 4 bytes. So earlier it was pointing here, and when we do ptr+2 it will point to the third location. Similarly we perform subtract operation as well. Let's say if I am writing ptr-2, suppose it was pointing here, and if I do ptr-2 then this will point here. And suppose you are having pointer of same data type, then you can perform subtraction operation on these pointers as well. This is ptr_1 minus ptr. It will give you value 1 because I am incrementing this pointer by 1 here and storing it into this pointer ptr_1. If both are having same data type, then you can do subtraction operation on these pointers as well. But you cannot perform multiplication operation or division operation or modulus operation. These operations you cannot perform. Next, let's understand what is function pointer. This is also a very simple concept. It looks bulky, but this is really a very simple concept. Suppose you have function add which returns the summation value, and taking 2 arguments of type integer, then you can take pointer for this function add. And how can you take that? Yeah, it's simple. What is the return type of this function? Int. So I have taken int. Then I'll take pointer for this function which is taking 2 arguments, right? And what are the type of these two? Integer, right? So I'm taking integer comma integer. So its declaration is done. So now we can do assignment for this addition function here. So function equals to add. Here name itself gives the address, and you can do dereferencing like this. You can call with 1 or 2, let's say. So this will work for you. And assignment can be done in another way also. Function equals to ampersand of add. So this also works, but when you are using ampersand symbol here, you must need to use asterisk key operator, means a star symbol. So you will have to call like this. Is similar to the normal variable pointer. In variable pointer also what we do, we take the data type. Here also we took the data type. We declare a pointer. Here also I have declared pointer with a star operator. And extra what we have to do, we have to just mention these argument data type. What are the argument data type it is going to take? Let me stop here. I hope you would have understood all the concept. If still you are having any doubt, please let me know in the comment box. I'll try to answer those, or I'll create a separate video for that. Thank you so much for staying throughout the video. Stay tuned and I'll see you soon.